What's up, ladies and gentlemen? Here we go. Section 2, continuing this section 2. Last video that we talked about was how do you factor any quadratic expression written in standard form. And I went through how we took a standard form like this, whether the b was 0 or it wasn't, doesn't matter, and we put it in factored form using our 7-step, I guess if you will, method, whatever, just a factoring. And we checked it, of course, that was a 7-step. This video, still section 2. We're going to add one step to it. Now, as I transition this slide, I want you to notice what changes. So this one is how do you factor. This video, though, is how do you solve. So last one was how do you factor. This one is how do you solve any quadratic expression written in standard form. Now, I don't know if you noticed this either. This is new. When we talk about solve, guys, we are talking about an equation. If you're solving something, there's got to be an equal sign. There's got to be equal something that you're trying to find the actual value for any type of an equation, no matter what it is, that solves it, that makes the actual equation true. So back to the beginning here, factor was just an expression like this. Solving, you're going to see an equal sign. Now, it might not be equal to 0. You might have it all bumbled up. But you're going to have to write in standard form and then rock and roll from there. So here we go. That's the idea of this video. You got the I guess, graphic organizer, if you will, there in front of you. So let's do some examples. Here we go. Okay, so before we get into anything really tremendously, let's do this. Let's first recall what solving an equation is. Remember, when we're solving, all you're doing is this. You are getting the variable by itself, and you're finding the value for x that when you put it in here would make this equation true. That's what solving really is. Now, you can look at this right away and say, oh, that means x has to be 14. Yes, because 14 plus 3 does give you 17. Mathematically, remember we did this. We subtracted 3, which gave you 14 here, which meant over here on the right side you're just left with x. So either way, doesn't matter. That's the idea behind solving. I'm not teaching you how to solve. It's what you're doing. You're finding the value for x that when you plug it back into the equation, 17 equals 3 plus 14, that equals 17 on the right side and 17 on the left side, so it works. That's the general scoop. Over here on the right, yes, you could kind of guess what you want it to be, but again, you could say, okay, well, 4 is what it is, because 2 times 4 gives me 8, plus 1 gives me 9. Or you could just simply do the math and get 2x equals 8, divide both sides by 2. That's great, that gives you a 4. So either way, doesn't matter. Again, I'm not teaching you the idea of how to solve. I'm teaching the idea, again, reminding you of what solve is. You're finding the value for x that when you plug it back in here would actually work. Okay, let's move over to this. Now, moving down your actual graphic organizer, solve the quadratic equation. Let me take a quick commercial break and tell you, many times you're going to see it written like this. It's going to say, hey, find the zeros. And I'm going to show you at the end of this video what it means by zeros. And they might also say, it might also say find the roots. So if it says find the zeros, or it says find the roots, it means the same thing, solve the quadratic equation. So get x by itself and figure out what x has to be that when you plug it back in, it actually works. Now, x isn't always the letter, because look at the example I gave you here. It's an a. So in this case, I'm looking for what a has to equal to make this equation work. Now, time out. If you notice this, I actually don't even have an equation over here. This is just an expression. So what I'm telling you is, oh boy, if it said solve, you would never have something that's written like this. It has to be, and write this on your paper, there has to be an equal sign over here. I'm going to make it equal 0. Once again, it's not always going to say equal 0, but there will be an equals for sure. So let's do this a while. Let's put all the equal 0 down through here. Let's put all the equal 0 down through here. That's why I left a space for you. Okay, so I have all the work over here to the right done for you. Of all the steps that we talked about in class, step number 1, factor out a GCF. Yeah, there's no GCF, so that's already taken care of. Step number 2, fill out the x thing with the thing. Okay, I'll do it down here. So the x thing, x. So I do a times c, which gives me 2 times 15, which gives me positive 30. I do this guy right here is the b, so I put 11 down here. So 11 goes right there. That's a weird color. I'll use a different color so you can see it. 11, there you go. So I need 2 things that multiply to give me 30, that add to give me 11. 3 and 10, no. 4, 5, and 6. There we go. So positive 5 and positive 6. So there's my factors. That's going to work. So I break up this middle term into that 6 and 5. Remember, again, we talked about this in class. It doesn't matter whether it's 6 and 5 or 5 and 6. Either way, at this example here, I got 6 and 5. Okay, so then that's step number 2. So we did step 1, we did step 2. Find the pair. Whoops, sorry, we did step 3. So now we use those paired factors, to rewrite the original equation. Oh, wait, check, we did that. Woo! So now we're on to step 5. Factor out the GCF. So we look at the first thing, and yes, I'm flying through this because you should already know this, regardless. So here's that thing. I look at the GCF that happens to be a 2a. When I factor out 2a, I'm left with a plus 3. That's what I got right there. And then I look at the second group of things. I factor out a GCF of that, which happens to be a positive 5. When I factor that out, I get a plus 3. That's what is right there. So that's step number 5. Step number 6, I now finally get this thing, and I take the a plus 3 and put it in the first parentheses. Beautiful. And I take what remains, the 2a and the plus 5, and I put it in the second parentheses. That is beautiful. So that is all of the steps, and then we do steps number 7 to check it. We FOIL it. A times 2a gives me 2a squared. A times 5, the outsides gives me 5a. The insides gives me 6a. And the last ones gives me 15. When I combine this together, like terms, I get plus 11a, plus 15, and check, baby, 1, 2, 3, 4. We got what we started with. So all of that is all well and good. It's all wonderful. It's all stuff for sure that is, if you will, we already know that. We know how to do those steps. Let me erase this. I'm going to need this. Let me pause for a second. So there's all of that. That's great. Now here's the scoop. Again, like I said in class right before you left, this is the deal. You're going to use the same exact 7 steps when you're given an equation like this that it asks you to find the zeros, the roots, or just solve. But you're going to add one more step, and you need to add this on your sheet of paper. It's already there. But step number 8 is you're going to use this thing right here called, I'll put it right here in black, the zero product property. Zero product property. And we affectionately call this thing ZPP. Yeah, you know me. That's exactly right. So we're going to use ZPP to actually finish this thing up and solve the actual equation. Now you're like, what do you mean zero product property? Well, the zero product property, you can look in your book, basically says this. If I have two things, no matter what they are, I'll call one A and I'll call one B. If I take those two things and multiply them, product, and they equal 0, zero product property, it says either one of these things, A or B, have to be 0 in order for this whole entire thing to be true. They both could be 0, but either one of these have to be 0. So, for example, if I had 3x in here for A and I had 0 for B, well, guess what? 3x times 0 is 0. So if B was 0, great, the product would be 0. The zero product property says one of these two factors, or both, have to actually be 0. That being said, how does that translate to what you just did over here? Well, after we went through all of our steps, we got our first particular binomial and our second binomial. The ZPP would tell me this thing right here, A plus 3, either that thing is equal to 0, or the other scenario would be is this, that 2A plus 5 is equal to 0. So I take this first binomial, set it equal to 0. I take the second binomial and set that one equal to 0. And all I do is I've just created two very simple equations, of which I just go back to elementary school, not really true, pre-algebra, and solve these equations by just subtracting 3. So I get A equals -3. So there's one of my solutions. And then the other one would be if I subtract 5, that gives me 2A equals -5. I divide by 2, beautiful. So I would get another possible solution, that's right, another possible solution of A equals -5/2. So all I did step 1, step 2, down to step 7. All of this stuff is exactly like we did over the past couple of days and mastered those things, mastered them. We have one more step. We just do ZPP, and all that means is I just simply take these buddies right here, whenever I get these little factor things, and I take A plus 3 equal to 0, 2A plus 5 equal to 0, solve it. So here are my two solutions. My one solution would be -3, or my other solution is -5/2. So sometimes you'll see it written like this, sometimes you'll see it written like I did, where it's just -3 or -5/2. Sometimes you'll just see it written like I've circled. This is a legitimate answer, this is a legitimate answer, these are legitimate answers. They're all the same exact thing. So, you got two solutions to it. That is beautiful. So it's a little different than what we did here. Back here in these first ones, we only had one solution. X was 14, or X was 4. Over here, we got two possible solutions, -3 and -5/2. Now, for the sake of the length of this video, I'm not going to do it, but here's the scoop. That just means, that tells you that you've now, guys, found that -3, if you plug it back in here for A, and you do all the order of operations, follow what Aunt Sally tells you, you would actually get a very, very legitimate, true equation. You would get 0 happening over here on the left side, which would equal 0 on the right side. That means it's a solution to the equation, because when you plug -3 back in, it works. It gives you a balanced equation. Same thing with -5/2. It is so beautiful. Now, let me do this for you. Let me show you what it actually means by zeros, or aka the roots. I'll tell you what 0 is. So let me show you this. Hold on one second. Now let me show you what I've just done. I've actually gone to a graphing calculator thing online, and I've graphed this for you. We used this in class a couple times, this whole program, which is cool. I graphed 2x squared plus 3x plus 15. And what you see is it's a parabolic shape, which it should be. The A is positive, so it's going up. You could have easily found all the stuff that's on here, but what I want you to notice is this. Remember what you just found. The answer was A equals -3, and A equals -5/2. What I am showing you is something extremely powerful, because where you're finding the zeros, it's where y is equal to 0 over here on the x-axis, aka what you're actually finding is the x-intercepts. So when it says find the zeros, it's what it means. Where y is 0 and y is 0, this bad boy is crossing at -2.5 for x and -3 for x. That's exactly what it's showing you. So zeros just means that's where the actual parabola crosses the x-axis. I hope you write that down. That's important, man. That's awesome. So that's pretty cool. So all this being said, we did all of our steps. We just added one more. Again, ZPP. Yeah, you know me. So we just set them equal to 0. Now here's what I want you to do. At the bottom of your paper, I want you to take this one right here, and I want you to actually solve it. Now notice, it is an equal sign. So there's an equation. It's a quadratic because it's a squared. This one is not quite exactly like the one we did because it's not equal to 0. So if you wanted to add a step before all of it when we're solving, you want to make sure it's in standard form first. So I'll give you a hint. That's right. What I would do is I would take this 50 and I would subtract it. So subtract 50 from both sides, which means now I'd have x squared minus 15x minus 50 equals, this thing goes away to 0. So there you go. So now you have it in standard form. Beautiful. Of which now you can take that bad boy and follow your steps. So factor it, set both these equal to 0, and find your two answers. See you in class. Rock on. Later.